all my viewers. I am Praveen Karthik, and today we will be talking about some basic concepts for astrophysics, specifically waves and spectra. In physics, mathematics, and such related fields, a wave is a propagating dynamic disturbance, that is, the change from equilibrium of one or more quantities. Amplitude is the maximum distance a particle moves in a direction, crest, before it changes to opposite direction and travels in the same distance, trough, in that direction from equilibrium. Wavelength is the distance between two consecutive crests or two consecutive troughs in a wave. It is also one oscillation. Frequency refers to the number of waves that pass a fixed point in unit time. It also describes the number of cycles or vibrations undergone during 1 unit of time by a body in periodic motion. Waves can be periodic, in which case those quantities oscillate repeatedly about an equilibrium resting value at some frequency. When the entire waveform moves in one direction, it is said to be a traveling wave. By contrast, a pair of superimposed periodic waves traveling in opposite directions make a standing wave. In a standing wave, the amplitude of vibration has nulls at some positions where the wave amplitude appears smaller or is even zero. Waves are often described by a wave equation, standing wave field of two opposite waves, or a one-way wave equation for single wave propagation in a defined direction. Two types of waves are most commonly studied in classical physics. Mechanical wave is a local deformation in some physical medium that propagates from particle to particle by creating local stresses that cause deformation in neighboring particles too. For example, sound waves are variations of the local pressure and particle motion that propagate through the medium. Electromagnetic waves such as light can travel through a vacuum and through some media. There are three main light spectrums we normally understand: the ultraviolet spectrum, visible spectrum, and infrared spectrum. Ultraviolet is known as UV and infrared is known as IR. Electromagnetic, that is EM waves, according to their frequencies or wavelengths, have more specific designations, including radio waves, infrared radiation, terahertz waves, visible light, ultraviolet radiation, X-rays, and gamma rays. UV light consists of rays which have very short wavelengths and is shorter than violet. Visible spectrum consists of the seven colors which we can view. The IR spectrum consists of wavelengths which have rays which are much longer than red. Let me read out the different types of radiation. First is gamma rays. Their frequency in hertz is about 10 raised to 20 to 10 raised to 24. The wavelength range is less than 1 picometer. The radiated objects at this temperature are more than 10 raised to 8 Kelvin. Typical sources are in nuclear reactions and they require extremely high energy processes such as a gamma ray burst. X-rays come next. They have 10 raised to 17 to 10 raised to 20 hertz. Their wavelength can be anything between 1 nanometer and 1 picometer. The objects radiated at this temperature can be anything between 10 raised to 6 to 10 raised to 8 Kelvin. The typical sources of X-rays are gases in clusters of galaxies, supernova remnants, and the solar corona. Next comes ultraviolet radiation. Its frequency is 10 raised to 15 to 10 raised to 17 hertz. It can have a wavelength as small as 1 nanometer up to 380 nanometers. The radiated by objects at this temperature are 10 raised to 4 to 10 raised to 6 Kelvin. Typical sources of ultraviolet light are supernova remnants and very hot stars. The visible frequency range is 4 into 10 raised to 14 to 7.5 into 10 raised to 14. The wavelength range can be anything between 380 nanometers or 750 nanometers. 750 nanometers is what you would see as red and 380 nanometers is what you would see as violet. The radiated by objects at this temperature can be 10 raised to 3 to 10 raised to 4 Kelvin. In other words, 1000 to 10,000 Kelvin. And the typical sources of visible light is stars. Then there is near infrared, which can be 10 raised to 14 to 4 into 10 raised to 14. So its wavelength range is 2.5 micrometers to 750 nanometers. Radiated by objects at this temperature are 10 to 10 raised to 3 Kelvin. The typical sources are cool clouds of dust and gas, planets, moons, etc. Next comes infrared radiation, which has a frequency of 10 raised to 13 to 10 raised to 14 Hz. A wavelength range can be anything between 2.5 micrometers to 25 micrometers. Radiated by objects at this temperature can be again anything between 10 to 10 raised to 3 Kelvin. Then there are microwaves. They have 3 into 10 raised to 11 to 10 raised to 13 Hz. They have a wavelength of anything between 25 micrometers and 1 millimeter. Radiated by objects at this temperature are less than 10 Kelvin. Typical sources are active galaxies, pulsars, which I will explain in a later episode, cosmic background radiation, etc. Radio waves have a frequency of more than 3 into 10 raised to 11 Hz. Sorry, less. The wavelength range is greater than 1 millimeter and the radiated objects at this temperature are less than 10 Kelvin. Typical sources are supernova remnants, pulsars, and cold gases. Some very important concepts related to EM, that is electromagnetic waves, are transmission and media. Transmission is the passage of waves with or without any charges to the wave through any matter or medium. Absorption. Some media result in lossy transmission, that is, some electromagnetic energy is lost within the media. This is known as absorption. Light waves, it can be characterized by refractive index. Electromagnetic waves themselves do not carry heat, but absorption of these waves by the medium heats the medium. Then there is reflection. Some media will return the light waves upon incidence on their surface. Reflection does not necessarily be near 100% of incident light. Refraction. Refraction is the phenomenon of a wave changing with its velocity within a medium. And diffraction is when a wave exhibits a diffraction when it encounters an obstacle that bends the wave or when it spreads after emerging from an opening. Diffraction effects are more pronounced when the size of the obstacle or opening is comparable to the wavelength of the wave. Interference. Whenever the amplitude of two or more waves add or cancel each other, either fully or partially, they are said to have interference. Polarization. Light waves are transverse. That is, the oscillation associated with each wave is perpendicular to the direction of propagation. A beam of unpolarized light consists of waves moving in the same direction with their electric vectors pointed in random orientation about the axis of propagation. Plain polarized light consists of waves in which the direction of vibration is the same for all waves. In circular polarization, the electric vector rotates about the direction of propagation as the wave progresses. Dispersion. Multiple wavelengths are carried by particles from a source. They are split as per their frequency. It is called as dispersion. Best example of dispersion is when white light shines through a prism. Momentum. Waves carry momentum and imparts it to the medium. Energy. Waves have energy and they can carry energy even in vacuum. Pressure. Waves exert pressure and they can be captured in a radiometer. I thank all my viewers for their support and enthusiasm. I thank my school teacher and my parents for teaching me, encouraging me, and helping me in accessing high quality content. Credits go to respective sources for the extracts of information I understood. They are Wikipedia and various textbooks. This content is curated by me, but none of the sources have endorsed this recording. Thank you.